In 0-6, we will be multiplying probabilities. Our only objective today is to find probabilities of independent and dependent events. So let's figure out what they are. If the occurrence of one event does not affect the probability of a second event occurring, then the two events are independent. So let me underline that. Independent events are taking place when one event happens and the second event is unaffected. And here's the formula for it. So the probability of A and B happening equals the probability of the first times the probability of the second. Now notice the multiplication symbol is here instead of the addition. The biggest difference is the word and versus or. If you see the probability of this or happening or that happening, that's from yesterday's lesson 05, we would add the probabilities and subtract the overlap. The biggest difference today is the word and. If you want to find the probability of this and that happening, then you must multiply the two together. An example, a coin is tossed and a die is rolled. What's the probability of the coin landing on tails and rolling a 3? So tails and rolling a 3. So the probability of tails is 1 out of 2. And the probability of rolling a 3 on a die is 1 out of 6. We multiply together and we get 1 out of 12. If the occurrence of one event does affect the probability of the second, we call those dependent events. An example of dependent events is drawing a card from a standard deck of cards, not putting it back, and then drawing a second card. To find the probability of drawing a jack and then a queen. In this situation, we modify the multiplication rule. We first find the probability of drawing a jack, 4 out of 52, times 4 out of 51, 4 on the top because there are 4 queens in the deck, and now 51 because we didn't place the card back into the original 52 card deck. And so when we adjust the total pool, that's called a dependent event. The probability of an event B occurring, given that A has already happened, we call that a conditional probability. And it's represented by this symbol P with a parentheses B and then a vertical line of A. We say probability of B given A, P given A, or such that A has already occurred. If two events A and B are dependent, meaning the second probability is affected by what happens first, then the probability that A and B will occur is here. So the probability of A and B equals the probability of A, event number 1, times event number 2, given that whatever we are after in the first event actually did happen. So let's talk about this in an example. A bag contains 12 red, 9 blue, 11 yellow, and 8 green marbles. If 2 marbles are drawn at random and not replaced, what is the probability that a red and then a blue marble are drawn? So red and blue equals the probability of red, 12 red marbles out of a total of, let's see, if we add those together, we get 40 times a blue marble. Now, there are 9 blue marbles out of 39. Okay, now this comes out pretty nice. It comes out to 9 over 130 after you simplify everything. And we could also write that as a percent. It's approximately 6.9%. Now, for the sake of argument, let's say that what's the probability of red, draw a red marble, and then another red, given that a red marble was taken first. So we have to take that into account. 12 out of 40 times, now instead of 40, we put 39 because we're drawing two marbles. We pick one marble, then a second one comes right after. But this time, we are changing it to 11. And we do that because we have to assume that what happened in the first event actually did occur. If there were 12 marbles and the probability of that is 12 over 40, when we go in for another marble, we have to assume, and we're hoping for a red, we have to assume that a red one was taken because we need the most up-to-date and accurate results. So we take 12 times 11, 40 times 39, and let's see what we get for that. And it comes out to about 8.5%. So sometimes now we will be after the conditional probability, the second event occurring in general. So let's take a look at how do we solve for the conditional probability. If A and B are dependent events, then the conditional probability of an event B occurring, given that A has already happened, is this. Now this should make sense because I'm going to copy down the equation from the previous page. The probability of A and B equals the probability of A times the probability of B, given that A already occurred. If we were going to solve for that in this equation, we would divide both sides by P of A and get this equation. Now, so sometimes we want to solve for the second event, the conditional probability. So in this example problem, it says, at a restaurant, 25% of customers order chili. If 4% of customers order chili and the baked potato, find the probability that someone who orders chili also orders the baked potato. So if we look at our formula, the probability of B given that A already occurred, well, the first event would, in this example, would be the people ordering the chili. And the second event would be of those people who order the chili, what's the chance that they're going to go on and order the baked potato if we know that 4% of the population in general order the chili and the baked potato. But of the 25% of the people who sit down and order the chili, we want to know what are the chances that from that moment they're going to order the baked potato as an add-on or something like that. So our formula would be the probability of B given that A happened is equal to the probability of A of A and B, which was the 4%, the 4% of customers. So you could write it as 4 over 100 or 0.04. The probability of P and B, so those are the folks who order chili and the baked potato in general, divided by the probability of P of A, the 25% of people who order just the chili, also known as 0.25. So either one is good here, as long as you understand that the 100s will cancel out and become 4 over 25, or 0.16, which is 16%. So it stands that the probability of people who order the chili and then move on to order the baked potato, 16% of those folks will go ahead and do that. Okay, a bag contains 8 red pencils, 6 yellow pencils, and 5 purple pencils. 2 pencils are drawn one at a time and not replaced, what is the probability that the second pencil is purple, given that the first pencil is red? So here we go. We want to find the probability, the conditional, the probability of B given that A occurred. So that'll be the probability of A and B divided by the probability of A. Now in this example, the first event would be our A, so a red pencil, and the second event would be our purple pencil. And so let's go ahead and solve this. P of A and B, well, if I have 8 red pencils out of, let's see, 8, 14, 19, times the probability of getting a purple once a red was chosen is 5 over 18, divided by, because this is the P of A and B, this is my numerator. Now the P of A in my denominator is just the first event, which was my 8 over 19. Well, notice here that the 8 over 19's cancel, and I'm left with my answer of 5 over 18. And this should make sense, because going back to the original, the probability of P and B, that equals the probability of A, the first event, times the probability of B given A happened. Well, this is what we're after. In the P of A and B, we are after the second item in that equation because it's the second event taking place of the first one already occurring. So 5 out of 18 is your answer for this one. Okay, in this last slide, there are 7 example problems that kind of give you a good sense of what we will be testing you over. So the answers are provided for you here. The 7 problems, highly recommend go through them, try solving all of them without using the answers at first, and then when you're done, come compare your answers with mine and ask your teacher for help if you need it.